If I can make a start then. Thank you for coming this evening. I've got a long presentation, but I'm not going to take that long on it. There'll be opportunity to get a copy of the presentation. I can send that through to you. That will be on the website. But first of all, the reason we're here to start off with is we have an affordable heat store. It stores 8 times the energy you would expect in an equivalent tank. And the guys at the UEA were instructed to validate that. And they've done so in spades. Before the invention, it was recognized that a power shower would completely destroy the thermocline of a store. You could hypothesize on how it would work, why it didn't work. But there's no like seeing it for yourself. So the first one I'm going to show is a power shower. And okay, we're about to turn the shower on. There it goes. And the hot hurtles down to the bottom, the cold hurtles to the top. The whole thing is mixed. And Mummy, Daddy, the shower's gone cold. Then we have a look at mine. Now this is actually running, but it's a bit boring. Because there it is, and there it will blinkly stay. So we'll move on. We'll move on to the actual thing you'll see on page 10 and 11. This is a 210 litre hot water cylinder. And it's going to take a little while. And the reason it takes a little while is because you can get so much water out of this tank. And you'll notice that the colour stays 85, there's no mixing. That initial mixing, which vastly disappears later in the process, is simply when the water first came into the cold water tank. So we're still drawing off energy, and we're going to draw off enough water for 14 consecutive showers. If you've got a power shower and you get 3-4 showers out of it, good luck to you. This will completely change things. You'll have 14 perfect showers. And that's what the invention is. So let's compare it with current technology. And we're going to take the market leader, who's selling his tank for £1,910. It's not as efficient as mine. It'll only store 9.8 kilowatts. Mine will store 17.1 kilowatts. The purchase price, I'm saying 500, but we're probably going to get it down to the 350 mark. And whilst one is inaffordable, the other one is affordable. Now, all works with the shower power booster, because the shower power booster limits the flow from the tank to multiples of 4 and 8 litres a minute. Now, I've made some changes to make that even better, but people take out power showers and deliberately fit shower power boosters because they get better showers, which is why my product gets consecutive 5-star reviews when people actually take out these money-glugging power showers and put my shower power boosters in. So we know that's going to work. And I'm going to skip through these because you can actually apply it to new buildings. You can put coffin tanks, you can put 48 hours of storage in to a new build. And this just explains how you do it. But when you do it, there are wondrous things that happen. I've missed the slide, go back. The demand for water in a home is very close to what the demand for electricity is. So at 2 o'clock in the morning, there's very little water required by the houses. Therefore, there's loads and loads of spare capacity in the mains. Good thing? No, bad thing. It means the pressures are high and all the mains pop off at 1, 2 o'clock in the morning. So you get more leakage, more bursts. And then at some times of the day, the very times when the pressure is the highest, people aren't taking water, I said that. You can actually fill up your tanks. So you're putting absolutely no additional demand on the pipes. So the pipelines can supply much bigger areas of housing. And how do I know that? Because I worked at Anglian Water, and I've been working for water companies for 30 years. I was the most senior water design engineer in Norfolk. We did Norfolk, Suffolk and Essex. I am telling you that if you put that storage into a house, you will reduce the amount of water that the source works have to produce because they can even it out over a period of time. You'll reduce bursts and you'll get more water from the same water main. And everything you do is beneficial. And I got a little device which is coming in from Estonia which will help us do that. So, potable heating and the effect on heat pumps. Heat pumps are very inefficient because what they're trying to do is heat water to 65 degrees C where they could heat central heating a lot easier, a lot simpler. And for that reason, they're probably twice what they should cost. The effect on new housing, I'm hoping to get a housing developer involved because they can then build houses where they wouldn't normally be able to. There are destructive technologies. There are power showers, which I've mentioned. There are electric showers. There are lots of things in homes which waste energy at the wrong time. And I'm going to do a booklet in connection with this project which will explain the energy savings for each and every application in somebody's home. I'm going for the low-hanging fruit. The first ones I'm going to go for is power showers. Because quite frankly, you'll save £400 a year. You'll save 219 tonnes of water. And you'll reduce your gas consumption by 18%. And I know if you've got a power shower, you've got a gravity system and you've got a gas boiler or oil boiler, I know you've got everything you need for me to do the most efficient job and make things better for you. We've got issues where we're going to have to talk to the right people. Want to get Clive Lewis on board. I've got some question and answers. Some ones which I'll probably leave up there so that the team can answer. And let me explain how the pilot works. Basically, you've got Norfolk Industries who employ people, disabled people. They have agreed to take on the entire management of the scheme. All I need to do is feed in materials from the suppliers, like the big factories that make tanks, etc. Get them delivered to the works. They appoint the plumbers. They make sure the plumbers get what they want. They make sure the customers are happy. And me, I step back and say, thank you, that's my part, John. Offline, what we need to do is get this project moving. And one of the issues I've got is, because it sounds so incredible, I need incredible people to actually support it. Or not so much incredible, but credible people. So people like Clive Lewis, get him along to a meeting of the UEA, Norwich City Council, and myself, to discuss the water saving issues. Because these people need to be in front of experts. I need a meeting with Octopus Energy. I want to get the best rates for you guys, and I think Octopus Energy are probably the best people to work with, but I'm not hung up on that. We've got an issue of constraint payments. I don't know if you know, but £1.5 billion was paid to wind turbines to switch them off this year. And that energy could have been given to customers free of charge. But there's somebody who doesn't want that to happen, and there's a big hoo-ha broke out a week ago where Ed Miliband said, you've got to compensate the wind turbines, you can't give it to the customers because there are no London customers near wind turbines, big wind turbines. So to even out the field, I don't know. Someone's got the wrong end of the stick. But Octopus are very keen on letting people have low-cost energy when it's available. So I want to be on his side. We need to meet with influential people. The ultimate aim of the pilot, and I'll hover on this one, because I see the affordable heat store as the first step to a low-cost air source heat pump. It takes all the complexity away from the air source heat pumps. They can do what they're best at, which is heating air for central heating. You can get all the storage and all the benefits with this tank, and I see no reason why it can't marry in with a hybrid heat pump. And because it does what it does, I want to see if we can get the £7,500 for the people on the trial. Because you paid £7,500 if you do away with your gas in your home. But at the moment, that's only given to people who use the suppliers who give you £15,000 units to give you £7,500 off. It's not given to the people who'd give you a £7,500 unit with £7,500 off. And I want to get to the point where this does not just benefit society, that it benefits the consumer. So my laser focus is to try and get some energy costs to everybody on the trial. There's a 2-year warranty with anybody who takes part. You'll be registered on a database, and we'll be approaching the energy companies with that database saying these are the people with the storage that you need to sort out your grid. How about a decent rate for the electricity? And that sort of takes you through it. We've got some model questions and answers. Do you want me to take any question before we all get up? Shall we rise, gentlemen? Right. So on the far side, we've got James Mills, who's Norwich City Council. Then we've got Jack Panther, the hydraulics engineer. And Stefano, who's the energy store specialist. And me, the guy who was crazy enough to put this thing together. So I've put some questions up on the board. Do you guys want to take one, or somebody want to raise a question from the audience? And sort of ad-libbing here, so don't...
Well, I'm happy to work through those questions in order if you want to, Alan. Yeah, so first one looks like it's for me. So I work for the environmental strategy team at the Forest. Oh yes, Yes, so I work for the environmental strategy team at Norwich City Council, and essentially the focus of our work is around decarbonisation and what we're going to do about climate change. There's a target for Norwich as a city to be net zero by 2045. We as a council, we have over 15,000 social housing dwellings that we manage that we've got to essentially retrofit and decarbonise by 2045. And essentially, we're open to all ideas and solutions, really, in sort of how we're going to approach that. So, sort of Alan came across our radar and told us about the work he was doing with UEA. It was of interest to us, and that's kind of why we've got on board so far, ready to sort of support it and learn more about what it is really and how we can support this pilot. So, but yeah, so in terms of answering that question, why we want to promote energy and water saving, again, it's all in pursuit really of our goals, mitigating climate change. In order to decarbonize, you need to first sort of improve energy efficiency really, and then electrify everything ideally. And this is one of many options basically that we can explore as a solution for retrofitting our homes. So that's kind of why we're interested in it. And water saving equally because of its environmental implications. We all sort of read the headlines about water usage, and especially as extreme temperatures and things come along and you get more drought conditions, as we've been saying lately, obviously water saving and water efficiency is as important as ever really. So yeah, that's kind of why we've been interested in this and learning more about this idea really. Yeah.
Okay.
Shall I hand on to the next one? I think it's I'll hand on to you guys to say more about your work as a university, what you've been studying around it.
Well, I will start just by giving the context of how we start this. So just to publish us a bit also how UEA, I guess, and our school collaborate with SMEs, just for the sake of the public or whoever is seeing these videos in the future. So back in April, was it? Yeah, back in April, Alan contacted us about this idea, and of course it was in the context of research we do in the School of Engineering, Mathematics and Physics. And we do have a really nice availability of funding within the institution, which is indirectly funded by Innovate UK, which is about supporting 3 months projects between university, so between academics, in this case me and Jack, with incoming SMEs with really interesting idea that they probably need a bit of backup by universities and know-how. So that's how we start this, and it was a really nice 3 months project, which just recently concluded a couple of weeks ago.
It concludes today. This is the final meeting.
And yeah, with really nice implication, and I think also from a research perspective, it gave us some good opportunities to use our tools. So the videos that were shown, of course, were part of the project deliverables, and it was all about fluid dynamics. So I guess I should pass on the details of that to Jack, and then I can come back later about system level, I guess.
You've warmed it for me. So maybe it's useful to just talk a little bit about how the technology works and how we were involved, specifically with addressing some of the key technical challenges, or rather proving some of the claims that Alan was making. So the idea is that within the hot water tank that you have within your homes, under conventional operation, you have thermal stratification. I'm a lecturer, I've got big glasses, and normally I've got elbow pads, so I'll throw some big words at you. The idea being that the hot water that's already heated within the tank will float to the top. It is literally less dense than the cold water underneath. So you get a layer of hot water floating on the top, and a cold water body floating underneath. The idea is then that when you want a shower or you're running your hot water taps, you draw off the water from the top of the tank, and of course it's hot, and that's exactly what you want. Alan came to us then and said, well, actually, there's a whole lot of wasted space within that hot water cylinder. It's all that cold water that's in the tank. You could also heat it up. When the electricity is cheap, when the sun is shining, you could put on your heater and heat that water up and literally save that hot water for literally a rainy day. The problem is that very delicate balance a very delicate balance exists within the hot water tank. The density difference between the hot water at the top of the tank and the cold water at the bottom is not very much. We're talking less than 1%. So really any minor disturbances is going to mix that hot water with the cold water underneath. And that's bad news because it results in cold showers, or at best case, lukewarm showers. So how do you store energy in your existing hot water cylinder very, very carefully without mixing the hot and cold reservoirs? And that's what Alan's innovation is all about in this context. It's about how do you very carefully pump the existing hot water from the top of the tank down through the middle of the tank to the bottom to then diffuse that heat within the bottom layer. And as you're doing so, then reheat the top layer. So you're replenishing the top layer at the top. What this means then is that as you're storing thermal energy in the bottom of the tank, you're maintaining your nice usable hot water in the top of the tank for your showers, for your hot water. So this is what Alan proposed. You said it does work. You've done the testing yourself at home, but really needed the detailed insight of a computational fluid dynamics expert to show exactly what was going on inside. So that was the aim of this 3 months research project specifically. It was to get one of my PhD students on board and to do a detailed project simulating what was going on inside of that hot water tank using our state-of-the-art simulation software that we enjoy in the Department of Engineering. And the core outcomes of this was that we now know how quickly you can store energy without destroying that delicate balance, without destroying your nice hot water supply at the top of the tank. And it's a quite usable outcome as well. The rate at which you can store energy is perfectly decent, and while still being able to draw off a nice hot shower. A secondary outcome, though, which was quite surprising, although, Alan, you've known all along, is that if you do try and draw off water too quickly, then you get what we saw in the video earlier. You actually then do indeed mix the entire tank, and so you destroy all your hot water that you've carefully stored up. How fast is too fast? Well, really, it's when you take a power shower. It's that sort of rate. So then this comes into another of Alan's innovations, which is the power shower booster. So almost indirectly, if you like, we showed that actually the power shower booster technology was an effective way to still have hot showers at the quality that you would want from a power shower, but without destroying the hot water reservoir that you've got in your hot water cylinder. So those are the project outcomes. I think Alan's happy with what we've found, and certainly we've proven the innovations that he's made. So,
Yes.
next.
So what do you see as the potential for taking this technology further? Because at the moment, it's sort of very much just this heat storage tank. But there's a heat storage tank with potential. You got potential, girl. So how could this work? And I understand you've got a recent tie-up with Hethel.
Yeah, absolutely. Do you want to talk about integration with PV?
Yeah, I mean, I can start with this, and then we can talk about Ethel in a moment. I mean, there are a couple of things to say. So the first thing is about the integration of this technology with PV on the roof, or even with micro wind, or even, again, try to basically actually use this oversupply of electricity from offshore wind is quite crucial. So the moment we have an electrical heater combined with Alan technology, so the heat store, we can actually make sure that we either really embed that electricity into heat into the tank at exactly the moment we need it without needing to curtail, in the case of offshore as well, and paying lots of billions of pounds per year. And this is something I teach to my students as well in year 3 when I teach energy storage. We have one of our students here in front, so he will get this stuff next semester for sure. So this is a prequel, let's say. So definitely there is a direct integration with any, let's say, kilowatt level renewable solar or micro wind on the roof. And I think the other key message that I think I actually loved the first time I talked with Alan, again, before we even start the project, is when he was talking about the hybridization of this technology with the heat pumps, because it is a fact that heat pumps are really bad to pump heat from really big difference of temperature. So the moment we decouple the domestic hot water from the space heating is a win-win from both sides. So we don't need to throw away heat pump. We don't want to, obviously we cannot use just Alan technology to cover everything, but there's a really nice kind of win-win, really nice marriage between the two. So it doesn't destroy the perspective of using heat pump to electrify our space heating, but definitely we can cover the domestic hot water with, again, this simple, cheap and cost-effective solution that Alan is proposing, and that, again, that we prove is working. On Eiffel, I'm going to leave this to Jack because he actually recently met them. So it's really good that you take over on this.
So so we've obviously concluded now a very technical project, giving a detailed insight into what's happening just within a single hot water cylinder. What we like to do next as academics is actually take that technical, that fundamental understanding and show how it can be applied in the real world and demonstrate actual impact to real people, right? That's what we're all about. So what we have in mind then is a project going forwards in which we are developing this technology along its innovation pipeline. And the next step is to actually get a pilot project with hopefully a local innovation cluster. So Hethel Innovation are the county-wide innovation controllers in Norfolk, and they support a lot of small businesses, startups, to actually upscale and innovate and expand and promote the efficacy of what they're doing. So that's exactly what we want to tap into. We want to show, actually, take a real life-size demonstrator, a hot water cylinder of the correct size, couple that with the heat storage technologies. And also as part of that, we would quite like to couple this with solar water heating. The idea being that if you've got hot water panels on your roof, you can actually couple this to the thermal energy storage system and actually store energy when the sun is shining, obviously, effectively within your hot water cylinder, again, without destroying the hot water layer at the top. So that's the next step of our technological demonstration. Obviously, it requires us to submit some funding. That's the way these things work. You require innovation grants to be able to demonstrate the efficacy of these things. Following on from that, or indeed parallel to that, is where Norwich City Council comes in, Norfolk County Council comes in, actually demonstrating the influence and impact of this technology in real contexts, so in the home, that real people are using, not just in some bunker in some innovation side. So the next stage in the project then is really to, yes, get these energy storage devices in people's homes, see how they operate within normal human usage, and tailor them, figure out what are the teething problems, how they can best be used, how people use them, how people don't use them, or indeed misuse them, and take things from there, really. Ultimately, I think the aim is to demonstrate that this really is an energy storage technique which is cost-effective and can be deployed nationally, and really does contribute to the UK national decarbonisation strategy.
Would it be possible for one of the participants in the trial to actually have this integration with a heat pump? Do it in the field, and the lucky person, it's a roulette, and the winner gets a free heat pump. But no, it would be nice to have it in the context of a real house and a real person, and Norwich isn't a long way from you, so it's a good place to do it. Just throw that one on.
Can I ask a question? I've got a question. One is heat pumps. Has anyone done any figures on how much cheaper they are to manufacture? Are you ready to 40 degrees, not 65? Has anyone done any data on that?
Well, I've done probably more than most, and what you got to do is actually do it to prove it happens. But there is anecdotal evidence. If I go back to the presentation, where are we? Come on, baby, come on, baby. There. So basically, every air source heat pump has got one of these babies or a similar one. Maybe it's not £1,900, maybe it's £1,800. You got a bargain. And it costs £1,000 to install it. So you got £3,000 before you start. And that's just the complexity of putting the equipment in to heat water as well. It is not the inefficiency that you create through trying to heat that additional temperature. That's probably another couple of grand, £3,000. But I'm only pulling figures out of the air because I can only say you won't need one of those tanks, so save £3,000.
Yeah, I don't want to sort of drag us up. I was thinking more the actual, there's a lot of resistance to heat pumps because of noise, because of lots of factors that put people off, and electricity consumption, and separate issue, what we're paying for electricity. But if what I was inquiring is if any manufacturer or anyone was being approached to find out how much less it would physically cost to manufacture 40-degree heat pumps. Would they be physically smaller? Would they have less environmental impact for audible and what have you? And that would be obviously an incentive for your system. And also those cylinders are absolutely huge. I know as someone who's put them in and been responsible for it. Getting rid of those is going to save a lot of room in a lot of houses, especially modern houses at school. And that's a diversion to what I actually want to ask you about is Norwich City Council is a really good, have you done anything with the technical services? Yeah. Because I listened to you, I'm thinking, the tower blocks, they have loads of issues, because you have to pump all the water up, your cylinders and things like that. That is low-hanging fruit. Yeah. And with the CHP issues, if you could save on producing electricity, that is really low, and that could possibly be something that would actually put Norwich on the map. Because if you develop that technology, I would have thought that's scalable and saleable.
Yeah, sure. So, I mean, that's where. So, my manager, Phil Hunt, who's sort of our environmental strategy manager, that's exactly the kind of thing that he's speaking to our housing team about, really, in terms of looking at where could be suitable properties to put into this pilot. That's the kind of opportunity, as you say, that we could look into, really. Yeah.
Thank you. Can you explain what a hybrid heat pump is? Because I think I know how an air source heat pump works, but I don't understand what you're actually talking about in a hybrid heat.
Okay, so you got a house, it's got a gas boiler, it's a very big house. It's impractical to have a full sort of heat pump. So you have a hybrid heat pump, which retains the gas boiler. This gets rid of the gas boiler and puts the water storage, and it would combine with a regular off-the-shelf hybrid heat store. So what we've got to do is get the manufacturers of hybrid heat stores along and say, this is what we're going to do. We know what you do. Just make sure we've got all our eggs in a row. And a hybrid heat store just does the heating, okay? It does central heating.
I mean, the thing is that let's begin at the beginning. You've got one of these things in, is that right? One of these cylinders that stores heat efficiently. Yes?
Yeah, yeah.
So you want to use that to heat the water for the house, for the radiators.
Correct. I'm going to listen. Yeah.
So how does the heat pump heat the water? Because we've looked into getting a heat pump. They're talking about 45 degrees, which means great big radiators and all the rest of it. So what are you going to do that's different? You're going to have a heat pump, presumably. Which,
Yep.
What does that do? Does that heat that water to 85 degrees?
No. No. So what you're using surplus renewable energy to heat your water. Right. And if we can get it for nothing on a windy night, that's what we're going to do, right? So you take the hot water completely away from the heat pump. Okay. Now all the heat pump has got to do is concentrate on heating the air temperature in your house to 21 degrees C. Okay. And there's a presentation slide which I really rushed over. I'm not going to go back to it. So there's two sorts of heat pumps. There's one sort which heats a radiator to 40 degrees C so that it can heat your house to 20 degrees C. There's another one which you would find on the Costa Brava when you're on holiday, which is a heat pump that directly heats the hot water in the room. Now for a direct heat, the hot water, no, hot air, air to air, sorry.
So it's a reverse air conditioner, and the hot water comes from...
That's one of them. So there's an air-to-air source heat pump, which is regarded as hybrid because it doesn't do hot water. Okay. And there's one that does radiators, which is regarded as the full works, but the strange thing is that the heat pumps use an immersion heater to heat the water to 65. So they're no different to what we're doing. But it depends who got the grant and who negotiated it. So one load of heat pumps gets $7.5 grand and the others, we'll see.
The point was made about the volume of these things and how large. I mean, I've seen water tanks for ordinary heat pumps and they're enormous. How big is this thing going to be?
1.5 meters high, 450 millimeters wide. I know that because it's the one we tested. It's a 210 litre cylinder. Yeah.
Well, that, you're just talking about the hot water system.
Yes.
So I missed the operating slides went so quick I couldn't match the operation. You're separating the heating system from the hot water system.
Correct.
So your system is hot water.
Hot water alone. It's simply hot water.
I understand that controlling the temperature of water in the cylinder can be done in an efficient way. And that's using an immersion heater to heat it, albeit overnight, which is similar to economy.
But normally what would happen if you've got just the normal immersion heater, it heats the top 1/3 and the other 2/3 are cold. To create a heat store, you need to heat 100% of it so that you've then got this energy storing. As you saw the drawing, I hope you can get 14 showers out of the tank, 1.5. Yeah, well, it's an issue if people have got power showers because you're lucky to get 3 showers out of it. And then you...
By power shower, you mean a pump?
A typically pumped...
Not an indirect cylinder, which is effectively a power shower but without a pump.
Right. So I marry this in. There's a booklet which is going around called the Shower Power Booster. And the magic is the SP22S, which boosts the hot and the cold.
Well, what page is that?
I'll just see if I can find it. Okay, if you turn to page 25, replacing a traditional power shower with a shower power booster, two 15-watt shower power boosters have the same effect as a 3,000-watt pump. And that sounds incredible, but it's true. And people send in reviews, they love it. And a lot of people take power showers out and replace them with these little pumps, a little micro pump.
I can understand that because you're controlling the temperature in a very
It's controlling the shower in a very special way. And because they're a small pump designed for optimum flow at 4 litres a minute, they are so much more efficient than a big power shower. So instead of getting all the noise and the vibration and the churning and the aggro of a big power shower, you just get a nice shower.
No. But you're still, with that shower side, you're still leaving a cylinder for hot water off the, if you're looking to heat pump. And that's
The air source heat pump should not need a cylinder. No, I don't think you're talking another cylinder.
why? How do you control the heating without sufficient volume of water? Because that's how a heat pump works. It's got enough water in the system to heat up slowly.
This is where the complexities come in. Right. This is where the complexities come in and what system you can marry it in with, which is why we need organisations like Heffel to look at it. I mean, all I can do is say there's potential if you don't have to heat the water to 85 degrees C in order to get it to 65. So the equation is, I believe it's going to be substantially cheaper. How much cheaper, I don't know. Gary.
So if you've got a system where your hot water is heated as you use it, this
Yep.
doesn't work with it.
You're talking about combi boiler? Yeah, you can replace a combi boiler. And that used to be the thing I really laser focused in until I was told, no, we've got to get rid of combi boilers. You've got to marry up with a heat pump. But you can actually do away with the combi boiler with one of these tanks. But what I would say is that it wants to be on your journey towards a heat pump rather than doing it for the sake of doing it now. But there will be a booklet that will work out what the comparative costs are, and you can make that decision. And what I'm saying is the trial will be going ahead. You need to register online if you want to be part of the trial. Normally you would pay £10, which gets you a booklet, a visit from a plumber, and get everything priced up and gets you registered on the scheme. For anybody who's attended tonight, the £10 is waived. So you can automatically just join up. And then when we've identified people, we offer a complete package, which is the plumber paid for, the tanks from the distributors at the cheapest price I can get, and a 2-year warranty on the job. So you're not getting some cowboy coming along. You're getting a proper plumber like Adam sitting there, who's one of the plumbers who is going to be fitting these. It's a small world. So have I covered that?
You also said something about needing gravity feeds. So if you haven't got an attic,
I could refer you to a book. We are the only pump that works with a Fortic tank. And basically it's the only pump that need something like 2 centimetres of head to work. A normal pump, by the way, I should have brought some so I could show you what these pumps are. But if you look here, there's where it is. The normal pump, a power shower, would need 1 metre head or it cavitates and burns out. 1 metre needs that much. My pumps need approximately 1 centimetre. They're designed to work with very little suction, so they don't pull in air, and they don't pull in water very well. But that means that you can put the tank next to the hot tank, and it's called a four-tick tank, where you combine the 2 tanks, or you have a close coupled tank. So if you've got a flat, you put a close coupled tank in and you can have the same system. And we'd even get the big tank into a little flat, because we're not talking huge tanks here. We're talking about a standard 210 litre tank, only many, many times more efficient than you'd expect that tank to be. So it's a revolution to use such a small quantity of water to produce such a huge quantity of energy for storage. And you can literally have a windy day 1 day of the week, and then 7 days later you're using that energy from when the wind blew. So it opens up a world of possibilities, but it's disruptive. And I need to say this at some stage. People have spent millions of pounds developing those tanks. They've got whole factories that make them. They hate me. They hate everything about making things simple. You don't need that complexity. The plumber, the rate is £250 a day. And it's an easy job because it's an easy system. I doubt if I could get any plumber to fit that mixed energy one for 500, 750, because complexity is not required, but it's disruptive. And when you tell people you've got this new technology which is really disruptive, you can see how many people have flooded in tonight. It's almost unbelievable. And it's difficult to motivate people because they get told so much bullshit, especially with the heat pumps and such like, because heat pumps don't work very well, but I think they could do.
So why doesn't the hot water that you've got stored in the tank cool down?
It does, but it cools down by 38 watts per hour. So basically, because you've got a simple tank, you've not got all these pipes coming in now, hemorrhaging the heat. That's where you start losing it. So that big tank has got a specific insulation value, about 58. That one's got about 32. And basically, if you heat the whole thing up to 85 degrees C, 2 weeks later, you're still over 60. Because you're only concentrating on getting rid of that heat or containing that heat within that cylinder. The cylinder will be 80 millimetre factory applied coating. And then we're having 4 layers of a high insulating value material wrapped around them. And you're right, there's no point in saving energy if it just clears away. But bear in mind that in the winter, that energy isn't totally lost anyway, because you're in a cold house. It'll help the heating. And in the summer, the temperatures are much higher anyway, so your temperature in your house is going to be warmer. But yes, it is an issue, but it's addressed. Okay.
I didn't get O-level physics. I'm very untechnical. And We have a combi boiler.
Yep.
And we have a shower that isn't a power shower.
Yep.
We don't use every day because it's not necessary to use a shower to be clean. So what could your system offer us in terms of water heating and space heating? Because it's just for clarification, because I'm so untechnical, I can't put all this together.
So what we could do for you is we could send a plumber around who would estimate what the cost would be to put a gravity system in.
But apart from the cost, if you leave the cost
Okay.
aside, what actually can you offer in the way of
Okay, so
water heating and space heating?
we're going to have to do away with gas boilers eventually, okay? And the route that we're going along is air source heat pumps, but they're not very good at the moment. What I offer is an interim step. You can turn your gas boiler off the entirety of the summer. You only need the gas boiler on when you're doing central heating. And you can take the entirety of the hot water onto your immersion heater using energy at off-peak times, which is what I do in my house. For years, I've had my gas boiler turned off. So it's an interim step. And if we play our cards right and we can get the grant money, not only as an interim step, but you'll be able to convert to a heat pump at a very economical cost. And it will be a smaller heat pump. It will be efficient. But how efficient and how small, it's early days. But that's where I want to be. My aim is not to do this for society's sake. It's for the consumer. It's for you to get a better shower, pay less for your energy. So that's where I want to laser focus this project. Hopefully that answers it.
I think so.
Could we go back to the air-to-air heat pump?
Yep.
Because that's fine. How do you get that warm air going all the way around the house?
It's only really suitable for flats and small buildings. So if you've got a flat and you've got, I visited a customer over there, Stella, and actually looked at the situation there. We can sort out the hot water fairly simply. We could sort out an air source heat pump to heat the air within a flat. But she tells me it's very noise sensitive around there. She's not very keen on air source heat pumps going at the wrong time of day. So it's not going to be right for everybody, but it's something that can be addressed. And in life, I think if you try and look at everything in a particular way, then you're trying to shoehorn the wrong solution just because you've got a particular solution. So for a flat, it might be air to air. In a house, it could be air to radiator. And we just need to look at the economics, and we need to get divorced from the idea that just because you spent a lot of money developing a project or product which is no longer needed, it's like the old gas lighting, it's got to go. But it's difficult with a disruptive product to get people to like you. And that's the situation I'm in at the moment, where these guys like me because they actually like the product because it works. And there's so many people out there that have got vested interests. I mean, even if it's down to fitting a particular boiler, all these plumbers, they go on courses for the particular boiler's installation. And they're paying £1,000 for training a year in order to keep updated on a particular boiler. So it's very, very cliquey, the plumbing industry. And if you're not in that clique, then you're an outsider. And if you're an outsider, you don't quite get the same reception. Okay. Any other questions, or shall we bring this to a... Go on.
So if my combi boiler's coming to the end of its life,
Yep.
it's worth thinking about replacing that with a cylinder.
Yes, and you've also got all the maintenance costs of the combi boiler. The maintenance costs, if it's running all through the summer, it's going to put more strain on it.
Yeah.
And also you got huge inefficiency because you're starting up and you got the gas light lit, you got the boiler heating this water. Yeah.
Yeah. So, but it,
Yeah, just to add to that, it's slightly unfortunate that as we move to combi boilers, of course, we've all ripped out our old hot water cylinders and airing cupboards and things like that. But it's widely appreciated that actually now we're trying to wean ourselves off gas central heating. We really need to be putting our hot water cylinders back because they're these thermal energy stores and they're so good for national level grid balancing in our electricity system. So I think that's where the lay of the land is for the future. We will be putting hot water cylinders back into homes.
And Carrie, if you sign up, then Norfolk Industries will send you a plumber, so you at least know what the cost would be.
Quick question. Your cylinders that you're proposing or you're using, have they got a secondary set of tappings for solar or for secondary
No.
heating? No.
No. What I didn't mention, I do actually integrate solar thermal with my heat store at home. And in the summer, it gives me all the hot water I need. So I don't bother with the heat store. I only bother in the winter. And I think you need to adjust your expectation as to what's happening. I bought a load of cheap solar panels, put 2 on my roof, didn't think they'd work very well. They're working so efficiently. It's unbelievable how much energy that these 2 panels are putting into my system. So I've got all the heat storage capacity. In fact, I've got a 500 litre heat store. But since I'm getting free hot water, which I did today and I do most days, I don't bother. So I don't think integrating those tanks with solar thermal is going to be a major issue. If you want it, it's going to cost you about another £125 to put a coil in. And we could put the coil in. Just ask. Yeah.
so you've got a 3 kilowatt system, so we just hook it into that. Solar panels, yeah.
Yeah, so is,
You buy cylinders, 2 coils, so they're readily available hours. That's how you manage it, which is your system. Can I just ask about your pumps?
yeah.
So how they control
Um,
what causes them to operate?
right, you're talking to the gentleman who designed it there, Phil Matthews. Basically, it's a magnetized water wheel. And the water wheel sits in the water, and when the flow goes past, i.e. you turned on a tap or a shower, the little water wheel thinks it's a compass to start with. It wants to point north, south. But eventually the flow increases, and it suddenly goes wee! And when it goes wee, 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 it doesn't actually go wee, 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 it spins. Well, the water wheel turns because of the flow of water. And then we've got a little Hall detector which detects this magnetic water wheel going north, south, north, south, north, south. We wait for 2 seconds, we turn it on, and then this was developed in October 2014, and we've been trying to do a better one ever since and failed every time. So the original design in October 2014 is the thing which was the sweet point which got it working. So it detects water simply when you take it because the water flows.
It is a power pump, you should be able to supply
Yeah.
3-volt supply to it. 3 volt.
Yeah, 3 amp supply, but each pump only takes 1 amp. Each pump takes an amp.
Well,
yes.
controlled by the water flow.
But when you're comparing it with a power shower at 3,000 watts, a 30 watt or a 15 watt motor, well, it's chalk and cheese. I mean, it's a mouse opposed to an elephant. But yes, these pumps, and they are the most highly acclaimed pump in the UK by customers.
So there's no setting up, they just
No,
basically put them in and they do whatever.
you fit them anywhere and everywhere.
Alan, can you talk to what the scale and ambition is for the heat store pilot?
Well, it sort of grew. I've got 3,000 heat stores, or I've got the devices for 3,000 units. I was crazy enough to spend £70,000 on materials, and they're all sitting up in a factory in a warehouse up north in Buxton, Derbyshire. And I want to turn all 3,000 into cash. And then I'll be a happy man. And then I'm not going to charge a huge amount, but because I can buy the materials direct from manufacturers, I can get a very good cost and I can sell it to people less than you would pay in a plumber's merchant. So I can control the costs. Also, I'm employing excellent plumbers who will need to keep customers satisfied. And the reason I believe they're excellent is because they've got a reputation for treating customers right. And they'll be there for one day and they'll fit this thing. And I've lost my train now. But basically, I think the scale is limited by the number of heat pumps I bought. Not heat pumps, but heat stores. And this is Robert, who deals with finance, getting grants. You've heard what we're saying. What is the potential of getting further grants for this? And this time is a way we can put them in more effectively.
Yeah, so the challenge we have at the moment is the current environment. The purse strings are being tightened across the board. The universities are seeing this. UKRI, which is UK Research and Innovation, the funding has decreased. Alan has just applied for, or rather just got the results of a grants application, which we hope would have underwritten this pilot for about £100,000. And that was unfortunately rejected. I need to do a bit of work to understand why it was rejected, so I thought it was a very strong application. Alan and I will have a conversation in terms of what a pilot in Norwich looks like, whether it's 10, 100, 3,000.
3,000.
And whether we can look at different funding sources as part of the pot of transition to net zero to see whether or not money can be allocated to reduce the cost of the installation. So effectively the pilot, I would try and angle would be partially underwritten by a grant, so to help with people coming on board and doing this transition and putting essentially a local immersion heater or a storage tank immersion heater back into their house.
Yeah. Maybe people like Carrie who are starting from a combi boiler and has got a lot further to go. If we could get grant money to assist that, that would be useful. Because at the end of the day, the kit's going to cost about £1,400, £1,500. You've got to pay back with a power shower of £400 a year. So power showers at the moment are the only ones where you can justify it on cost alone.
Yeah, so what you were saying in terms of the combi boiler, what you're advocating for phase one would be to put in the heat source in conjunction with the combi boiler. That would run essentially the shower during the summer months and potentially also throughout the winter as well, which reduces the strain on the combi boiler. It's also there available that at the point at which you need to replace your combi boiler, it can also potentially help with the integration of a hybrid heat pump.
Yeah.
Is that a good paraphrase?
It is, but you can go one step further because when I switched from combi boiler to heat store, the combi boiler was simply valved off. And for a lot of the time, I just didn't run the combi boiler on demand for hot water. So there are interim steps. But to really get good effect, as if you get rid of the coil into the heater altogether, and then you can reduce your thermal losses from your tank. Or you could do what I'm doing, just link up the solar thermal on the garage and get free energy in the summer. And by the way, I bought up hundreds of solar thermal panels, which I'm looking for a home for.
So, to continue, if you're maintaining a combi boiler for solar use,
Yeah.
that would only become less expensive, more expensive, if electricity was saving. The cost of the electricity would have to come down significantly in order to compete with the cost of the gas running the boiler in the summer, because obviously electricity is...
Not so. It all depends what tariff they give you. I'm on Octopus, so I pay about 7p a kilowatt for my electricity, and 8p for my gas. So I can top up with that energy every night.
So question linked with what you just said, is your ultimate goal to maybe look at having an immersion heater which has an API, so then like with Octopus and Tether, I'm guessing you're on the 7 pence. So then Octopus, when they've got excess electricity, can say, right, we can give you electricity at a cheaper rate and heat it and keep the heat stored to then outbalance the grid. Is that a goal?
Yes. I'm working closely with a firm in Estonia, in Tallinn. They provide a little plug which is linked to the internet, and it searches for the lower price in Nord Flex or something. But whether we got the same system over here, I don't know. But he is modifying it to fit a 3-pin plug. He was going to send me a sample ASAP, and he will do. And what I want to do is get in a meeting with Octopus Energy and say, look, this is the plug we got. Can it integrate with your system? Can we have the energy that is wasted when the turbines are running? Can my people have that? And then once you've got that, you're talking about comparison with gas. Once you've got free electricity, it's just wow. And also you're doing something for society. But you've got to start somewhere, and we're starting here in this room, reasonably attended, maybe not. but we've got something new. I think we've got something exciting, and we've got to spread the word.
If you had a fellow come round to look at your system and advise and quote, is one of the options going to be converting a combi to a system order and put the cylinder in? Is there a time likely to quote for that?
So the idea is, first, we're going to target people with power showers, okay? But that means that the plumbers are not totally engaged. So they will have the opportunity to visit other premises and quote on replacing electric showers, combi boilers, whatever. And the way I'm looking at running it is that £250, which is a fair price. I'm not screwing anybody. It's a good price. Gives you everything in connection with the heat store within the cupboard. Now, there will be possibly other work which he could do, which because he's on site, he's going to give you a very good price for it. And I want to record that price to make sure that plumbers are being fair. So if he's replacing your tap and he's charging a lot of money, I want to know. But also they'll be pricing up for replacing combi boilers. And you wouldn't go back to a system boiler, because a combi boiler, I think, can be used for radiators anyway. Yes, it can. Is that right, Adam? A combi boiler can be used for hot water central heating only.
Yes.
So you just leave your combi boiler as it is, dealing with the central heating, and just take 100% of your hot water with this new tank. And the new tank is going to cost around about £1,400, including the fitting, with a 2-year warranty. Okay. Thank you very much, gentlemen.
Thank you. Thank you for coming out on a warm Friday evening to hear about a heat store technology. I know it's not the most, on the face of it, the most exciting thing to come out and do on a Friday evening, but yes, thank you.